Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, so, Ji-young, I have to admit, I read the paper you sent me, and my brain is officially buffering, the title alone. Bilevel Autoresearch, Meta-Autoresearching itself. It sounds like a research paper that ate another research paper for breakfast.
That's a very apt analogy, Isabel. It is a bit of a mind bender. The core idea is recursive. We often use AI to research a topic, but here we're asking the AI to research, the process of research itself, to improve its own method of searching for answers.
Exactly, think of every current AI research assistant. It has a fixed loop. Search, read, synthesize, repeat. A human programmer designed that loop. We looked at it and asked, what if the AI could redesign its own loop, find its own bottlenecks and write the code to fix them?
So it's like giving the AI a wrench and saying, your job is to make this wrench better, while you're still using it to build something. That sounds chaotic and potentially brilliant. How does it not just break immediately?
That's the beauty of the bilevel framework. We have two separate but connected loops. The inner loop is the worker. It's doing the actual task, like optimizing a small AI model's training parameters to get the best score. It's focused on the asterisk what.
And the outer loop is the manager, or the architect. It's not doing the task. It's asterisk watching the inner loop work. It sees the patterns, the dead ends, the inefficiencies. Its job is to improve the asterisk how. It asks, is my worker searching in the best way possible?
So the outer loop, the meta AI, it literally writes new Python code, new search algorithms on the fly.
Precisely, and here's a key point. We use the exact same large language model for both loops. The meta level doesn't need a smarter, more expensive model. It just needs a different perspective, a different prompt. Its job is to be creative about process.
The results were fascinating. On a standard benchmark, the system with the meta outer loop improving the inner loop performed 5 times better than the standard static loop, just by letting it tinker with its own methodology.
5 times, that's huge. What kind of improvements did it make? Did it just speed things up?
It discovered whole new strategies. On its own, it generated code inspired by techniques from combinatorial optimization, multi-armed bandits, statistical design of experiments. No human told it to look there. It found them because the inner loop's default, deterministic search was too narrow.
The LLM has strong priors, built-in assumptions about what step to try next. The Metaloop's job was to break those patterns, to force exploration into areas the base model would instinctively avoid. It introduced randomness, strategic branching, ways to test multiple hypotheses at once.
So its superpower was making itself less predictable, to fight its own biases.
In a way, yes. It created mechanisms to overcome its own built-in blind spots. That's the metacognitive leap. Not just solving the problem, but improving the tool you use to solve all asterisk problems.
And that's the profound implication. If an AI can successfully meta-optimize its own research process, then in principle, that same recursive framework could be applied to optimize almost any process with a clear goal. The process of learning, the process of design, the process of discovery itself.
Okay, I need a second. This is a lot, but it's also incredibly cool. It feels like we're moving from AI as a tool to AI as a partner that can also sharpen the tools in the shed. Thank you both, Ji-young, for climbing this conceptual ladder with me. My brain is no longer buffering. I think it's just quietly rebooting.
Thank you, Isabel. Always a pleasure.
Thanks for having us.
And thank you for watching, everyone.